here at the Permo-Triassic boundary in the western salt range. So it's a Namal Gorge, and this huge mountain range is the southernmost range of the Himalayan fold and thrust belt. And we are here to discuss the Permo-Triassic boundary. We know that at the end of the Permian there was a mass extinction, and it is the largest biodiversity event in the Paleozoic, whereby there's a huge extinction of different marine and terrestrial genera and species, and new species appear. In the Paleozoic, we have a lot of brachiopods and tabulate and rugose corals, and we have these trilobites. So trilobites live in this ocean for 250 million years, but at this boundary those trilobites has got extinct, and this brachiopod corals and trilobite, they were replaced by ammonites and bivalves and scleractinian corals. Also, there were reefs in the Paleozoic, but after this event for 16 to 20 million years, the reef, they got their growth got suspended. You see here, this boundary is, you have this sandy kind of stuff at the base, so that's represent the topmost part of the Permian. And here you have these dolomite beds. So these dolomite beds are actually representing the Katwai member of the Mia Valley Formation, which is representing the onset of the Triassic era. And these dolomite beds are full of these ammonites and ceratites, while the lower beds of the Permian carbonates, you see that there's a huge section of the Permian which is full of the brachiopods, and then on top of that you have this white sandstone. So that's representing the topmost portion of the Permian, which extends over here. So this sandy stuff is a transitional environment between the lower late Permian carbonates and between these limestone and dolomite of the Triassic. So there is a gradual shift in environment, and you have the drowning of the carbonate platform of the Permian, and then you have this white sandstone which was deposited in a beach kind of setting, which represents a drastic sea level fall along this boundary. And then you have these dolomite beds. There are the main cause of this extinction, this mass extinction, is the hypercapnia. A lot of carbon dioxide was sent into the atmosphere, and because of that you have global warming, ocean acidity, and because of that you also have ocean anoxia. So all these parameters, the change in environment, the reduction of oxygen content, the stratification of the ocean, the ocean acidity, so all these were the causes of this extinction. And this change in environment, that is assigned to the massive volcanic eruption along the Siberian Trap. So that has sent a lot of carbon dioxide at the end of the Permian, where there is a change in the paleoclimate and paleo environment on the terrestrial and on the continental settings. That trap was intruded into the coal sediment. So when you are intruding the igneous rocks into the coal sediment, so there is also a massive release of methane, and you know that methane is 3 to 4 times severe greenhouse gas as compared to the carbon dioxide. So because of this hypercapnia in massive methane outbursts into the atmosphere, and it's mixing with the ocean system, has changed the paleo environment on the continent and on the ocean, and then you have this mass extinction. Some people say that there was a bolide impact on the earth crust, and because of that you have the dusting of the atmosphere and blocking of the sun rays, and because of that the primary productivity that goes down, because you cannot have photosynthesis in a dark environment, and that has caused the extinction, or it will be a combination of these two. So you see, the biota of the Permian is replaced by ammonite bivalves and the scleractinian coral. So you see these beds of the early Triassic age. So you have these ammonites, and you have these ceratites. So that's the overall expression of this boundary in Pakistan. Unfortunately, it's not a complete continental setting when you are going from late Permian to early Triassic. If that was a continuous continental setting, so that would that would have given us an opportunity to look into the continental environmental change in mass extinction slowly and gradually. Um, on the other hand, if it was a complete marine section in the late Permian and then in the early Triassic, so that would we should have, you know, then introspected into the marine realm, that how the marine environment changed and how that change has actually caused this extinction. Unfortunately, we have, you know, late Permian carbonates and early Triassic carbonates and dolomite, but in between we have the clastic setting. So that clastic setting, you know, that's a transitional zone. So we don't have that continuous record of continental setting or continuous record of the marine setting. But anyhow, overall, in the late Permian and in the early Triassic, there is, drastic visible change in biota, which we can see in the outcrop.